Welcome to a fresh episode by DDevOps Academy. Let's break down the concept of web engines. A web engine in DevOps is a software framework that runs, manages, and delivers web applications efficiently. What is a web server? Web server is a computer where the web content is stored. Basically, web server is used to host the websites, but there exists other web servers also, such as gaming, storage, FTP, email, etc. In simple terms, a web server is a computer that stores, processes, and delivers website files to web browsers. How it works. The web server responds to the client request in either of the following two ways. Number 1 is sending the file to the client associated with the requested URL. Number 2 is generating response by invoking a script and communicating with database. When the client sends a request for a web page, the web server searches for the requested page. If the requested page is found, then it will send it to the client with an HTTP response. If the requested web page is not found, the web server will send an HTTP response. Error 404 not found. If the client has requested some other resources, then the web server will contact the application server and data store to construct the HTTP response. Types of web servers. The most prominent types of web servers available in the market are 1. Apache HTTP Server Web Server 2. Internet Information Services, IIS, Web Server 3. Nginx Web Server 4. Node.js Server. Introduction to Apache HTTP Server. This is the most popular web server in the world, developed by the Apache Software Foundation. Apache Web Server is an open-source software and can be installed on almost all operating systems including Linux, Unix, Windows, FreeBSD, Mac OS X and more. About 60% of the web server machines run the Apache Web Server. Apache installation. apt install Apache 2, Debian, yum install httpd, rhel, directory structure appears in the picture. Apache configuration files and features include Apache configuration, ports configuration, Envvars, htaccess virtual host. Description. The main configuration file for the Apache HTTP server. On CentOS, RHEL, the file is typically named httpd.conf, while on Debian, Ubuntu, it's Apache.conf. Purpose. Defines global settings for the server, such as server root, modules to load, and general directives. Includes other configuration files for modular organization. Check the example directive for more understanding. Ports.conf. Description. Specifies the ports on which Apache listens for incoming requests. Purpose. Configures the listen directive for port numbers like HTTP 80 or HTTPS 443. Check the example content for more understanding. Case. Change or add ports for custom applications, e.g., listen 8080. Envvars. Description. A file to set environment variables used by Apache. Found in, etc., Apache 2, on Debian-based systems. Purpose. Sets variables such as the server's user, Apache run user, and group, Apache run group. Example content. Check the example content for more understanding. htaccess. Description. Upper directory configuration file that allows users to override server settings without modifying main configuration files. Must be explicitly enabled with the allow override directive. Purpose. Customize directory level settings, like URL rewriting, authentication, or access control. Example content. Check the example content for more understanding. Security note. Excessive htaccess usage can impact performance. Prefer main configuration files when possible. Virtual host. Description. A mechanism to host multiple websites on a single Apache server, either by domain name, name-based, or IP address, IP-based. Check the configuration and example configuration for more understanding. Apache Modules. Apache Modules are extensions that add extra functionality to the Apache HTTP server. These modules enable specific features, like enhancing security, enabling redirection, or supporting SSL, TLS encryption. Mod security. Description. a security module that acts as a web application firewall to protect against attacks like SQL injection, cross-site scripting, and other common vulnerabilities. Features: monitors HTTP traffic and applies customizable security rules. Protects against OWASP top 10 vulnerabilities. Logs suspicious activity for auditing. Example case: blocks malicious requests based on patterns. Configured via the OWASP mod security core rule set. To enable sudo a2 nmod rewrite sudo system ctl restart Apache 2. Mod rewrite. Description: a module for rewriting URLs on the fly. It is commonly used for creating SEO-friendly URLs, redirecting traffic, and enabling custom URL structures. Features: supports URL rewriting based on rules and conditions. Enables redirects, for example, HTTP to HTTPS, domain redirection, simplifies dynamic URLs into readable ones. Check the example rule directive for more understanding. To enable sudo a2 nmod rewrite sudo system ctl restart Apache 2. Mod SSL. Description: provides support for SSL TLS encryption, enabling secure HTTPS connections between clients and the server. Features: encrypts data in transit, protecting sensitive information. Configures SSL certificates and settings. Supports modern TLS protocols. Check the example configuration for more understanding to enable sudo a2 nmod SSL sudo system ctl restart Apache 2. Mod Proxy. Description: enables Apache to act as a reverse proxy, forwarding client requests to backend servers or services. Features: load balancing and caching. Supports reverse proxy for backend applications. Can proxy requests to HTTP, HTTPS, FTP, or AJP protocols. Check the example configuration for more understanding to enable sudo a2 nmod proxy sudo a2 nmod proxy _ HTTP sudo system ctl restart Apache 2. Mod Deflate. Description: compresses HTTP response data before sending it to the client, reducing bandwidth usage and speeding up content delivery. Features: supports compression for text-based content, HTML, CSS, JS, XML, etc. Negotiates with the client to ensure compatibility. Improves page load times. Check the example configuration for more understanding to enable sudo a2 nmod deflate sudo system ctl restart Apache 2. Common use case: mod security. Used to block SQL injections, XSS attacks, and other malicious traffic as a web application firewall. Mod rewrite. Commonly applied for creating SEO-friendly URLs, redirecting HTTP to HTTPS, and rewriting domain requests. Mod SSL. Enables HTTPS to secure communication by encrypting data between clients and the server. Mod Proxy. Helps in forwarding client requests to backend servers or balancing loads across multiple servers. Mod Deflate. Compresses text-based files, HTML, CSS, JavaScript, to reduce bandwidth usage and improve page load speeds. Let's deep dive into a virtual host. In this configuration, we are setting up a virtual host for our website, domain1.com. The line less than virtual host * 80 greater than tells Apache to listen for all incoming HTTP requests on port 80. Next, we define the server name as domain1.com, which is the main domain name, and the server alias as www.domain1.com. So both versions of the domain will work. The server admin directive sets the email address of the website administrator, in case users or the system need to report issues. Then, the document root points to the folder that contains our website files, in this case, var www.domain1.com/public_html. The directory index specifies the default page that will load first, such as index.php or index.html. Inside the less than directory greater than section, we define permissions and behavior for that directory. Options indexes plus follow symlinks disables directory listing but allows symbolic links. Allow override all lets the website use its own htaccess files for custom configurations. Require all granted gives public access to the site's content. Finally, the error log and custom log directives define where Apache should store error and access logs for this domain. The configuration ends with less than, virtual host greater than, closing the virtual host block. Now dive into htaccess. Here you can see, we're using the Apache mod_rewrite module to redirect traffic from one domain to another. The line less than if module mod_rewrite, C greater than checks whether the mod_rewrite module is enabled on the server. This is a safety check, so the code inside runs only if that module is available. The next line, rewrite engine on, activates the rewrite engine, allowing us to use rewrite rules and conditions. Then we have two rewrite cond lines. The first condition, rewrite cond %http_host, check html.com $OR, means that if the domain name exactly matches check html.com, this rule should apply. The OR flag tells Apache that if either this condition or the next one is true, the rule will execute. The second condition, rewrite cond %http_host, www.checkhtml.com checks for the www version of the same domain, www.checkhtml.com. Now, the rewrite rule line defines what happens when those conditions are met. The pattern, *, matches any request URI, basically, any page or file requested from the domain. The target https://www.google.com/$1 redirects the user to Google, keeping the rest of the path after the slash, represented by $1. Finally, the flags r equals 301, L, tell Apache to issue a 301 permanent redirect, and the L flag means this is the last rule to process if the conditions are met. The closing less than, if module greater than simply ends the block. In short, this configuration redirects all traffic from checkhtml.com and www.checkhtml.com to https://www.google.com. Using a permanent redirect. To be continued. This is just a beginning. More to explore in the next part.